afternoon. This is Mr. Phillips. This is going to be a two-part video about adding integers. This is from the lesson to actually Monday, Tuesday today, and it started last week on, I want to say Friday, because we got a few days off. But I'm going to take a few minutes to talk about the first part, day one of adding integers, and then I will stop the video, and there'll be a second video for day two, which is today and tomorrow, depending on when your child has class. All right, so let's skip forward on these slides. The topic for today, we're going to get through adding integers with red and yellow counters, and then the second video will be about adding with number lines and the rules. Our learning intentions, so students will learn how to add and subtract integers fluently. Today we're going to focus on adding. So to be able to add using red and yellow counters, we'll talk about what that is in just a moment. And the next two success criteria. So first is our do now, okay? This is simple matching equivalent expressions. Most of these are familiar to kids from elementary school. So we have 10 plus 15, which we should know equals 25. So therefore I'm going to drag the 25 over to match it with the 15, the 10 plus 15, okay? Take a second to try to do the rest, and then we'll pause and talk about it. So pause the video, take a second to try to match the rest of the expressions if you have not already, and then restart it and we'll go over it. So if you did that, you should have seen 4 minus 4 equals 0. 23 minus 19 equals 4. Then we have 5 plus negative 1, which should have equaled positive 4, but we don't have a positive 4, so we'll talk about that in just a second. 13 plus 17 equals 30. 7 plus 8 equals 15. And then one that we should not be familiar with because we're in middle school and we just started is this one here, negative 3 plus 5. Some of you figured this out in class. We knew that this was positive 2. I heard a bunch of different reasonings. One student gave the example saying that if you thought about it as you have 3 negatives and 5 positives, there's less negatives than there are positives, so they should take away from each other. And he came up with positive 2. Another student tried to relate it to real life and said that if you have negative, or if you owe somebody $3 and then someone gave him $5, he'd only have $2 in the end. And then for our last two, we're going to use some constructive reasoning here. So we don't have our correct answer, but we can replace one of these two. So we know it's not going to be negative 4. So we'll change this to positive 4. Place that here. And that leaves us with a 9, but we know 24 minus 13 doesn't equal 9, so we'll change that to what it equals, which is actually going to be 11. Okay, moving on to our next slide. So, like we said, we have 3 ways to solve. We can use red and yellow counters. The yellow counters, as you see, has a plus sign. They represent positive 1. So every time you see one yellow counter, that's the same thing as seeing just a regular positive 1. The red counters represent a negative. So every one red counter or red circle represents negative 1. Every one red circle represents negative 1. So let's work out a few examples together. When we solve these, we're going to do 3 steps. We're going to line up our counters to take away our 0 pairs and determine your answer. Let's first line up our counters. So from the top, okay, you can barely see it on my screen. There we go. From the top, we're going to pull down counters from here to represent. Now, will we use the red or the yellow? We're going to use the yellow once again because yellow represents positive. We need to represent positive 4. So to do that, I'll pull down 1, 2, 3, and 4 counters. This represents positive 4 so far. So now I've modeled or represented positive 4. Next, I need to represent positive 3. I'm going to use the yellow counters again because it's a positive number. So I'll pull down 1, 2, and a 3rd yellow counter. So now I have modeled 4 plus 3. This represents my positive 4. This represents 3. Next, I need to take away my 0 pairs. We haven't defined what 0 pairs is yet until this class. 0 pairs is when 2 numbers add up to equal 0. That's the simplest definition for it. 2 numbers add up to equal 0. So it's really when we can take 2 separate numbers or integers, because remember integers are numbers that are whole numbers that are positive or negative. And when the sum of the two numbers, or when we add them together, they equal 0, that's created a zero pair. So when I look here, do I have any zero pairs? Are there any two counters, any of these yellows I can add together that would then equal 0? No, because this is 1, this is positive 1. If I add them, they become positive 2. Add these together, it becomes positive 3 now, 4, 5, 6, 7. So I have no zero pairs in this particular example. So therefore, my answer is going to be just I take everything that's left over in step 1, I take all of my counters left over in step 1 and bring them over to step 3. So therefore, I have 1, 2, 3, sorry about the lines, 4, 5, 6, oops, and 7. So I've got 7 counters here. So therefore, my answer is positive 7 because they're all yellow. Okay, positive 7 because they're all yellow. Let's go to the next slide. So we're on slide 10 now. For slide 10, we have the question -4 plus positive 3. So our same numbers, but one of our integers changed. Our first number changed from a positive integer to a negative integer. Which one do we use once again? The red counters or the yellow to represent negative? We're going to use the red counters because the red represents a -1. So 1 represents -1, but I need to represent -4, so I need to drag down 3 more red counters. I need a total of 4 negative counters to represent -4. 4 red counters to represent -4. Next, I need to represent positive 3. I won't use the red because we know the red represents negative, so therefore I'm going to use the yellow counters. So now I have positive 3 modeled or represented for me here. Next thing I'm going to do is take away my zero pairs. Once again, zero pairs are when two numbers add up to equal 0. Zero pairs are when two numbers add up to equal 0. So let's look at our counters. We said each counter represents 1, right? We said this represents a positive 1 because it's yellow. This represents a -1. So therefore, when I add these two numbers together, if I have a -1 and a positive 1, when I put them together, they equal 0. So this is an example of a zero pair. This is a zero pair. Over here, I have 2 more zero pairs because I have 2 more reds that I also can combine with the 2 other yellow counters. I have 2 other red counters I could combine with the 2 yellow counters. So in this case, I have a total of 3 zero pairs. I have 1, 2, 3 negatives and 1, 2, 3 yellows. So these have made 3 zero pairs. These have all canceled each other out because -3 plus positive 3 equals 0. And now I look back at my step 1 and I see what I have left. All I have left over is a red counter. So I'll bring it over to step 3 and put that in here. So since I have 1, I'll put 1. But wait, I gotta remember this is a red counter, and red counters are always negative. So my answer is actually gonna be -1. Okay, let's go down to our next problem. So now we have 4 plus -3. 4 plus -3. I'll model my 4, which is a positive integer. Remember, integers are whole numbers that can be positive or negative. So I'll put my positive 4 over here. Then I'll model my -3. -3 will come down here. Red counters represent our negative. And I'll take away my zero pairs. I have how many zero pairs here? 3, exactly. Okay. This is a zero pair, so this is 1 zero pair. This is another zero pair. What did I do to that circle? I messed that one all the way up. This is another zero pair, and this is another zero pair. So now when I look at step 1, I try to see what I'm left with. I'm left with 1 yellow counter. And like we said, yellow represents positive, so my answer is +1. My answer is +1. Let's go to our next slide. So for slide 12, okay. Ooh, and Mr. Phillips says he's filled in already. Sorry about that. We have to represent -4. We have to represent -4. So down here is our -4 because we have to use the red counters and represent -3. -3 is over here with our red because -3 is a negative number. Red counters represent negative numbers. This time I have no zero pairs. Why is that? Because there's no yellows to represent. Remember, zero pairs means anytime, any two numbers that add to equal 0. The sum of two numbers that equals 0. -1 plus -1 ends up making a bigger negative number. So when I have nothing but red, there's no zero pairs. I must have a red, I must have a yellow. Meaning in short, I have to have a positive and a negative number to have a zero pair. So instead, I take everything that was in step 1, bring it over to step 3. My final answer is -7. Okay, if you need to take a second to go, if you feel like you're still at a 1 or a 2, rewind the video, go ahead and watch it again. Take your time on breaking it down. Okay? We're going to skip the lesson reflection for right now, and that's it for this first video. See you in just a second.